Hello, everyone. Today let's study the induction formula. Previously, we obtained the basic relationship between trigonometric functions at the same angle by using the geometric properties of the circle. We know that the most important property of the circle is symmetry, and symmetry, such as parity, is also an important property of the function. Therefore, we thought that we can use the symmetry of the circle to study the symmetry of trigonometric functions. The important role of the induction formula is to transform the problem of finding the trigonometric function value of any angle into the problem of finding the trigonometric function value of the angle between 0 and 2 of pi. The derivation process of the induction formula embodies the mathematical idea of the combination of number and shape and the transformation from complex to simple. It reflects the inductive thinking form from special to general. Let's review Formula 1 we learned earlier. Sine alpha plus k times of 2 pi equals sine alpha, cosine alpha plus k times of pi equals cosine alpha, tangent alpha plus k times of 2 pi equals tangent alpha. Where k belongs to the set of integers, will you describe this set of formulas in words? In fact, this set of formulas describes the same angle of the terminal edge, and the same trigonometric function value is equal. It can be seen from Formula 1 that the final edge of the angle rotates around the origin 1 circle, and the function value remains unchanged. We can use Formula 1 to convert the trigonometric function of the angle in any range into the trigonometric function value of the angle in 0 to 2 pi. Formula 1 studies that the angle with the same end edge and the same trigonometric function have the same value. Using Formula 1, we can convert the trigonometric function value of an angle in any range to the trigonometric function value of an angle within 0 to 2 pi. So, how to continue to convert the trigonometric function value of the angle between 0 and 2 pi to the familiar trigonometric function value of the angle between 0 and 2 of pi? We find that there are some angles whose terminal edges have some special relations, such as symmetry about the coordinate axis, symmetry about the origin, etc. So what is the relationship between their trigonometric function values? Please explore the relationship between the trigonometric function values of the symmetrical angle of the midpoint about the origin center. Let's take a look at this figure. In the plane rectangular coordinate system, let the terminal edge of any angle alpha and the unit circle intersect at point P1. Let the coordinates of point P1 be x and y. Rotate the terminal edge of angle alpha counterclockwise. And the terminal edge of angle pi and the unit circle intersect at point P2. Then P2 is P1's symmetrical point about the origin. Therefore, the coordinates of point P2 are negative x and negative y. According to the definition of trigonometric function, we can get the three trigonometric function values corresponding to the angle alpha. Sine alpha is equal to the ordinate of point P1, that is, y. Cosine alpha is equal to the abscissa of point P1, that is, x. Tangent alpha is equal to the ratio of the ordinate and abscissa of point P1, that is, y to x. Still using the definition of trigonometric function, we can get the three trigonometric function values corresponding to the angle pi plus alpha. Sine pi plus alpha corresponds to the ordinate of point P2, that is, negative y. Cosine pi plus alpha corresponds to the abscissa of point P2, that is, negative x. Tangent pi plus alpha corresponds to the ratio of the ordinate and abscissa of point P2, that is, negative y to negative x, that is, y to x. Let's compare the relationship between the values of two functions horizontally. We will find that the sine of angle alpha and pi plus alpha are opposite to each other. The cosine values of these two angles are opposite to each other. The tangents of the two angles are equal. From this we get Formula 2. Sine pi plus alpha equals negative sine alpha. Cosine pi plus alpha equals negative cosine alpha. Tangent pi plus alpha equals tangent alpha. Then this set of formulas describes the relationship between angular trigonometric functions whose terminal edge is symmetrical about the origin. Please answer the following two questions. Can you express this set of Formula 2 in words? For the trigonometric function value of the angle pi plus alpha, it is equal to the function value of the same name of alpha, preceded by a symbol of the original function value when alpha is regarded as an acute angle. The second question is, what angle evaluation and simplification problem does Formula 2 solve? We observe the characteristics of the angle. This set of formulas solves the problem of simplifying and evaluating the trigonometric function of an angle such as pi plus alpha. Next, can you prove the following formula by analogy with Formula 2? For this set of formulas, let's first observe the characteristics between corners. The terminal edges of negative alpha and alpha are angles symmetrical about the x-axis. We still use the definition of unit circle and trigonometric function to solve the proof of this set of formulas. Let us assume that the intersection of the terminal edge of the angle alpha and the unit circle is still P1. The intersection of the terminal edge of the negative alpha and the unit circle is P3. Since the terminal edge of the angle alpha and the negative alpha are symmetrical about the x-axis, their intersections P1 and P3 with the unit circle are also symmetrical about the x-axis, so the abscissa corresponding to these 2 points is equal, and the ordinate is opposite to each other. Using the trigonometric function definition of 2 groups of angles, we can get that sine negative alpha is equal to negative sine alpha, cosine negative alpha is equal to cosine alpha, tangent negative alpha is equal to negative tangent alpha. According to this derivation rule, we continue to complete the proof of the next set of formulas. Still using the proof idea of Formula 2 and Formula 3, let's first observe the relationship between angle pi minus alpha and the terminal edge of angle alpha. We will find that pi minus alpha and angle alpha are the angles with respect to the outer axis symmetry of the terminal edge. With the help of the unit circle, we still set the intersection of angle alpha and the unit circle as P1, and the intersection of the final edge of pi minus alpha and the unit circle as P4. Since the terminal edges of alpha and pi minus alpha are symmetrical about the outer axis, their intersections with the unit circle are also symmetrical about the outer axis, that is, the abscissa of P1 and P4 are opposite to each other, while the ordinate is equal. Then, according to the definition of trigonometric function, we can get that sine pi minus alpha equals sine alpha, cosine pi minus alpha equals negative cosine alpha, tangent pi minus alpha equals negative tangent alpha. The 4 groups of formulas obtained above are collectively referred to as induction formulas. Please observe these 4 groups of formulas and find out what structural characteristics are there at the left and right ends of each group of formulas. About this group of induction formulas, we will make the following 2 explanations. First, alpha in the formula refers to any angle. When we simplify the formula such as sine 1 plus pi and cosine 2 minus pi, we might as well regard 1 and 2 as alpha in the formula. Second, the structural characteristics of induction formulas 2, 3, and 4 are that the names of trigonometric functions at the left and right ends remain unchanged, the alpha angle remains unchanged, and only a symbol is placed in front. The sign judgment method is to look at the sign of the original function value when alpha is regarded as an acute angle. Next, we will use the induction formula mentioned above to find the following trigonometric function values. Let's start with the first topic, cosine 225 degrees. Since 225 degrees are between 0 degrees and 360 degrees, we only need to convert 225 degrees into sharp angles. That is to say, change 225 degrees into 180 degrees plus 45 degrees, and the terminal edge of this angle is in the 3rd quadrant, and the cosine value is negative. Therefore, using the derivative formula, it is equal to negative cosine 45 degrees, that is, the negative 2nd root 2. Let's turn to the second topic. Sine 8 pi of 3 in this problem, the angle 8 pi of 3 has exceeded the range of 0 to 2 pi. Therefore, let's turn the big angle 8 pi of 3 into a small angle between 0 and 2 pi, that is, turn 8 pi of 3 into 2 pi plus 2 pi of 3. According to Formula 1, the terminal edge of 2 pi of 3 is the same, and the sine value is the same, which is equal to sine 2 pi of 3. Continue to turn the angle of 2 pi of 3 into an acute angle, which is regarded as pi minus 1/3 of pi, since the final edge of pi minus 3 of pi is in the 2nd quadrant, and the sine value is positive. The result of its simplification is sine 3 of pi, that is, 2 of the root of 3. Let's look at the third topic. Sine negative 16 pi of 3 has a negative sign in this angle, so we need to deal with this negative angle first. If we regard 16 pi of 3 as alpha and is an acute angle, the negative alpha terminal is in the 4th quadrant, and the sine value is negative. Therefore, the negative angle turns into a positive angle and turns into a negative sine 16 pi of 3. Then, keep the minus sign, and continue to turn the large angle of 16 pi of 3 to between 0 and 2 pi, which is regarded as 5 pi plus 1/3 of pi. Since the terminal edge of angle 5 pi plus 3 of pi is in the third quadrant, and the sine value is negative, its simplification result is negative 3 of pi. The negative sign in front is copied, and the negative sign in the end is positive. The value of sine 1/3 pi is root 3 of 2. Please try the fourth question by yourself. In the fourth topic, the angle still has a negative angle, so our first step is still to turn the negative angle into the positive angle first. If 2040 degrees is regarded as an acute angle alpha, the final edge of negative alpha is in the fourth quadrant, and the tangent value in the fourth quadrant is negative. Therefore, tangent negative 2040 degrees first equals negative tangent 2040 degrees. Then we need to simplify the large angle beyond the range of 0 degrees to 360 degrees. Think of it as 6 times 360 degrees minus 120 degrees. From Formula 1 with the same terminal edge, its tangent value is directly equal to tangent minus 120 degrees. Copy the negative sign in front, and then we continue to regard 120 degrees as the acute angle alpha, so the negative alpha is the fourth quadrant angle, and its tangent value is negative. Therefore, the result of tangent minus 120 degrees is negative tangent 120 degrees, which is simplified to tangent 120 degrees by adding the previous negative sign. Continue to simplify in the direction of acute angle. 120 degrees is regarded as 180 degrees minus 60 degrees, and the final edge is in the second quadrant. The tangent value is negative, so it is equal to negative tangent 60 degrees, or negative root 3. So, through the above 4 questions, do you have any further understanding of the role of Formula 1 to Formula 4? Can you summarize the steps of converting trigonometric functions of any angle into acute trigonometric functions? We can conclude as follows. The first step is to convert the trigonometric function of any negative angle into the trigonometric function of any positive angle. The way is to use Formula 3 or Formula 1. The second step is to convert the trigonometric function of any positive angle into an angular trigonometric function of 0 to 2 pi. Remember, it's Formula 1. The third step is to convert the trigonometric function value of the angle from 0 to 2 pi into the trigonometric function of the acute angle with the help of Formula 2 or 4. It can be summarized as negative angle to positive angle, large angle to small angle, and finally to acute angle trigonometric function. Please complete the simplification of example 2. Tangent to negative alpha minus 180 degrees multiplied by cosine minus 180 degrees plus half of alpha cosine 180 degrees plus alpha multiplied by sine alpha plus 360 degrees, where alpha is the third quadrant angle. In the process of simplification, let me ask you a question. When you simplify cosine 180 degrees plus alpha, can you use the induction formula learned earlier? In fact, the answer is yes. Alpha in the induction formula refers to any angle, from general to special. Even if there is no condition that alpha is the third quadrant angle in this problem, we can also use the induction formula to resolve it. Let's resolve these 4 equations in turn. Let's start with cosine 180 degrees plus alpha. We regard alpha as an acute angle of 180 degrees plus alpha, and the final edge is in the third quadrant. The cosine value of the third quadrant is negative, so its simplification result is negative cosine alpha. Let's look at the second term of the molecule sine alpha plus 360 degrees. According to Formula 1, alpha plus 360 degrees is the same as the terminal edge of angle alpha, so the sine value is directly equal. Let's look at the 2 terms in the denominator. Tangent negative alpha minus 180 degrees. An angle is a negative angle, so let's put forward the negative sign in the angle first and change the sign inside the brackets. Then we take alpha plus 180 degrees as a whole and an acute angle, so the final edge of the negative value is in the fourth quadrant. The tangent value is negative, that is to say, it becomes negative tangent alpha plus 180 degrees. Then take alpha as an acute angle, add 180 degrees to alpha, and the final edge is in the third quadrant. The tangent value is positive, so the result of simplification is negative tangent alpha. Let's look at the second term of the denominator. Cosine minus 180 degrees plus alpha. The negative sign still appears in this corner, so let's first mention the negative sign and continue to treat the 180 degrees minus alpha in brackets as a whole. Then the negative corner ends in the fourth quadrant, and the cosine value is positive. Therefore, the result of its simplification is cosine 180 degrees minus alpha. Let's take the alpha in this formula as an acute angle. The final edge of 180 degrees minus alpha is in the second quadrant, and the cosine value is negative. Its simplification result is negative cosine alpha. We substitute the results of these four pictures into the original formula in turn. After the original formula is substituted, we find that there is a different tangent alpha inside. We use the trigonometric function formula of the same angle to transform tangent alpha into sine alpha then cosine alpha. After reduction, the final result is negative cosine alpha. From this example, we can conclude that when simplifying and evaluating trigonometric functions, we generally first consider the induction formula. The trigonometric function is simplified and deformed by using the induction formula to achieve the unity of angles. The number of function names is reduced as much as possible according to the transformation of tangent function into sine function and cosine function. In this way, the purpose of trigonometric function simplification is finally achieved. That is the content of this lesson. Goodbye.